When it asks you to classify a triangle by angles and sides, this is what it means. Equilateral triangles have 3 equal sides. Isosceles triangles have 2 equal sides, and scalene have no equal sides. Okay, so when you're classifying it, I need a classification by side. I also need a classification by angle. Acute triangle has all of its angles are acute or less than 90. A right triangle, 1 is 90 degrees, and an obtuse 1 is greater than 90 degrees, okay? And so you will do these both ways. You will classify both by side and by angle, all right? You do have an equal angular triangle that is specific to an equilateral triangle, where all the angles are the same measure as well. And so when it's asking for classification, it's asking for one of each of these, side and angle classification, all right? And you may want to add to it equilateral, because that means all 3 are equal angles. I mean, all 3 equal angular, all 3 are equal angles as well. Triangle sum theorem. This tells us that all 3 angles inside any triangle will add up to 180 degrees. So if you know 2 of the angles, then you know how to find all 3 of them. Something else I want to point out here is for isosceles triangles, then you know the base angles are congruent. So in an isosceles triangle where it has noted that 2 of the sides are congruent, you can automatically know all 3 angles if you only know 1. If you know a base angle, then the other angle is the same and you can subtract from 180. If you know the vertex angle, you can subtract from 180 and divide by 2 and you get the 2 base angles. So in an isosceles triangle, you can find all the angles by just knowing 1 for an isosceles. For an equilateral triangle, all 3 of your angles are the same. It will automatically be an equiangular. If they're all the same, they will all be 60 degrees. So combining what you know about sides and angles with the fact that all 3 angles add up to 180 can help you solve for even more information if you know more specific things about the triangle itself. Exterior angle theorem says that the exterior angle of a triangle is equal to the sum of the 2 opposite interior angles. So if I take this exterior angle, it's going to equal the other 2 interior added up, okay? And so number 3 deals with that. Number 6 deals with that. If you flip to the second page, it does some exterior angles as well. And so really pages 1, 2, and the top of page 3 have to do with your types of angles, your angle sum theorem, and your exterior angle sum theorem as well. And so those all combine for those several questions all the way up to question 17. So the first thing we talked about is just congruent statements, all right? So if they give you these 2 triangles and they want you to write congruent statements about them, order matters, all right? It does not matter which order you put the first one in, but the second one follows the order. In this case, they have listed A, B, C, and then the congruent. So we have to make sure that A, the angle A, if it is congruent to angle D, then those have to be listed in the same position. If angle B is congruent to E, they have to be listed in the same position. And then if F is congruent to C, same there. All right. And so then you can write any of these congruent statements from that. You could say A is congruent to D, B is congruent to E, C to F, A, B to D, E, B, C to E, F, A, C to D, F. All right. You can then calculate what the angle measures are if you're given some information on one or the other triangle. So if they have the measure of angle A, then I want the degree measure. If they have just an AB or just an AC, they want the length of the line segment, not an angle measure there, okay? And so this congruent statements helps you find a lot of information out about the two different triangles. From this, we moved into proofs. The different types of proofs that we have: side, side, side. That's when you have all three sides congruent. Side, angle, side. It matters where the angle is. If you have two sides in an angle, the only way to prove that they are congruent is if that angle is in between the two sides that you have congruent. Angle, side angle. You would use this if you have two angles and the side in between them. If you have two angles and another side, not the side in between, then it's going to be angle, angle, side, because this guy is outside of the two angles that you have, all right? Only ways to prove angles is if you have one in between, angle, side, angle, one on the outside, angle, angle, side. And then we had a special one specifically for right triangles, hypotenuse and either of the legs, all right? Hypotenuse leg is specific to a right triangle. And so those are the 5 ways that you can prove triangles are congruent. Now, in a specific proof then, you are looking for keywords to help you do that. And so I have this list here. You don't have to write them all down, but I want to point out some keywords. Bisects. That's going to be important. That's going to tell you 2 line segments are congruent. Or if it's talking about an angle, if it bisects an angle, it's telling you 2 angles are congruent. All right? Right angles. That's going to tell you you may possibly be looking to try to solve using hypotenuse leg. Right angles, hypotenuse leg. You'll notice this is bisecting an angle, right? So where this one was bisecting a segment and we had 2 segments congruent, this is bisecting an angle. Both of those, somewhere in the proof, you're likely going to use definition of a bisector. All right? Midpoint. Midpoint happens at a bisect, right, where they bisect. So if they tell you something's a midpoint, they're also telling you that 2 line segments are congruent. You see this notation here. That means perpendicular. Well, perpendicular lines form right angles. That may be important in your proof if it's a hypotenuse leg proof, all right? The other symbol you might see is this one, parallel. If you see parallel, you're likely going to use alternate interior or corresponding angles, all right, to prove the angles are congruent. And so you want to look for those key things in your given so that somewhere in the proof you can use one of those key things to move on with your proof and prove one of those 5 ways. All right? And then also we used corresponding parts of congruent triangles are congruent, CP, CTC. Anytime you are trying to prove a piece of a triangle, they want you to say this angle is congruent to this angle or this side is congruent to this side. This will be your last step. Always. You need to prove the triangles are congruent first by one of those 5 methods. And then your very last step will be, okay, the parts are congruent because corresponding parts are congruent. Okay, and so this is also one that we used in some of our proofs when it wants a piece of a triangle congruent.